Hey y'all, it's me, Mr. Cronigan, with another lesson on Nearpod. Hopefully you've watched the first lesson about motion and what causes motion. We saw that if a push or pull will cause an object to change its motion unless the forces are balanced, which will cause it to stay the same. Today we're going to talk a little bit more about that using Nearpod, so I need you to log into Nearpod with your app or on your browser. Today's code is FRGB, FRGJB, FRGJB. Click join. Waiting. Here we go. Click join session. All right, Newton's first law of motion. So Newton was a guy that a long time ago started making some observations about how the world works, and he came up with some really important laws that we still use today. The key points for today: an object is not going to change its motion unless something makes it. So things are going to stay the same unless something makes it. This is called inertia, which is the tendency to do nothing or to remain unchanged. Things don't want to do anything unless something makes them stay the same. Inertia. Thinking in your own words, describe what motion is. So hopefully you've got an idea of what motion is, either from experience or remembering what we talked about in class a few weeks ago. What is motion? How would you define it? Some people might say, well, it's just moving. Yeah, it is. But there's more scientific definition. So thinking about maybe a grid. How in a grid would you show something's moving? How would you know it is? When you're ready, you can record your answer. Click record. It'll type it in here for you, and then you can just submit it to me. What is motion? Motion is the change in position of an object after it is acted upon by an outside force. So when you pedal a bike to make it change its position. So when an object is in motion, it's changing its position. The only way to make something go in motion is add an outside force, an unbalanced force. So to push on the pedals, you make the bike go from this position to this position and make it change its position. We're going to watch a cool video of a crash test in the car. Be ready to write down what you notice and wonder. Here it goes. It's pretty short, I promise. Whoa. Don't worry, this is not a real person. It's just a huge doll that they use. What do you notice and wonder about what's happening? What happens to the car, right? And then what happens to the person? Notice the airbag right here. Yikes. All right, watch this. No airbag comes out. Interesting. So what did you notice and wonder? Right, at least two notices and wonder. So here's what I came up with. I noticed that the car stopped moving when it hit the wall. So as soon as it hit the wall, its motion was changed. I also noticed that the car stopped moving, but the crash dummy kept moving. So the car stopped, but the crash dummy kept going, hit the front of the car. I wonder, why did the dummy keep moving when the car hit the wall? Why didn't it stop with the car? I also wonder, did the dummy get more hurt when there was no airbag to stop its motion? Just what I was wondering. Maybe you thought of different things. Hopefully you did. Maybe you noticed things that I didn't or wondered things that I didn't. That'd be great. You'll hit submit. So this is Newton. He lived a long time ago. Like I said, he, by observing the world, came up with some really important laws that we still use today to make sense of what goes on in our world. The video you just watched was an example of Newton's first law of motion, which states an object at rest will stay at rest and an object in motion will stay in motion unless acted on by an unbalanced force. What? That's a lot. You might be thinking, What does that mean? Let's talk about each part separately. So the first part, an object at rest will stay at rest unless acted upon by an unbalanced force. Still kind of tricky, but let's think. This soccer ball is not moving. We say it's at rest. This soccer ball will stay at rest unless some force causes it to move. You can verify this at home. Put something on the ground. It's not going to move unless something makes it move. This is actually a really good thing. Think about if your table or chairs were just lying around all over the place. That'd be bad. So things stay at rest or stay not moving unless something makes them move, an unbalanced force. Looking at this picture, what could be done to these balls to cause them to not be at rest anymore or move? So you've got some soccer balls. What could we do to make them change their motion or go into motion? So I thought a force you could apply to move a soccer ball is a push with your foot. You could push the ball with your foot. That would cause an unbalanced force, cause the soccer ball to change its motion. You might have thought, well, you could pick up a soccer ball and throw it. That would be a good option. Some people might think, hey, maybe I could hit it with a bat or something. You could say, I could put it on a hill, let it go, and let the hill roll it down. Lots of options, but all of them require an outside force, an unbalanced force. So let's go to the second part. An object in motion is going to stay in motion with the same speed and direction unless acted on by an unbalanced force. What does that mean? Here you can see a soccer ball being kicked and it's moving through the air. But you also know that soccer ball is not going to stay up in the air forever. Why won't this soccer ball keep moving through the air forever? What causes things to come back down towards the center of the earth? I'm glad you're thinking with me. All right, let's see what we got. Label some of the forces that will cause this soccer ball to eventually come to a rest. So you can see that this soccer ball is up in the air. This lady must have just kicked it. What's causing the soccer ball to come to a rest? So what I thought of was something called gravity is pulling the soccer ball towards the center of the earth. So it's a big force pulling on it. I also thought of another force. It's when the air is rubbing against the soccer ball. You might remember when we say rubbing things together, we call that friction. Yeah, friction. So the soccer ball is traveling through air, which we know is matter, right? Made of particles. The particles in soccer ball are rubbing together with the particles in the air, causing the soccer ball to lose some of its energy. That with gravity is causing the soccer ball to come back down to earth. So both those are unbalanced forces. Yeah, I think that's all I got to say about that. A hint for you, if you want to label, I recommend using the text box like I did. It just makes it easier to write because it's hard to write with your mouse or your finger. Either way works though. Make sure that you are drawing your arrows in the right direction. Also, we don't know how big the force, well we do, but we haven't learned that yet, of gravity and friction are on an object. So it's okay just to draw the arrow with the direction and not write how many newtons there are of force. So basically, an objects that are resting or not moving, not testing, resting, will stay that way until an unbalanced force causes them to move. That's easy enough. We can observe that. It's helpful for our life. When objects are moving, they're going to keep on moving until an unbalanced force changes the direction and causes them to not be in motion. That also makes sense. Things keep on moving unless something makes them stop. We call this inertia. So sometimes people just call Newton's first law the law of inertia. So inertia is just the tendency of an object to resist change in motion. What that means is things want to stay the same. They don't want to get faster, slower. they just want to stay the same. So if something's staying still, it wants to keep on staying still. If something's moving, it wants to keep on moving. And it's going to unless something makes it stop. Here's a quick video, it's like 3 minutes, about Newton's first law of motion. I want you to pay attention to 3 things. First thing, is it possible for a runner that's running really fast to stop in 1 second? So notice that. Can runners stop in 1 second? Number 2, if something is at rest, is it going to change its motion? And then the third thing, what causes things to change their motion? So can a runner stop running in 1 second? Things at rest are gonna stay at until something makes them. And then what causes things to change their motion? Here we go.
Imagine you're sitting on a recliner chair watching your favorite movie on a lazy Sunday, and your mom calls out your name and asks you to run some errands. You can imagine how difficult it would be for you to get up and do the work. Imagine you're practicing for your 100 meters race on this track, and somebody asks you to stop immediately within a second. Will you be able to do it? What if you're suddenly asked to turn towards the right? Will you be able to turn immediately? The answer to both the questions would be a no. You can stop, yes, but gradually. You can also
It
turn,
takes time,
but not
that means.
sharply. And guess what? It's the same story with every object. Every object will continue to do what it's doing. If it's at rest, it will remain at rest. And if it's in motion, it will stay in motion. But what can change this? Yes, only an unbalanced force can change this. If it's at rest and an unbalanced force acts on it, it will move. If it's in constant motion and an unbalanced force acts on it, it may accelerate or change direction. And this is nothing but the Newton's first law of motion.
Here we go.
Here's the correct definition. An object at rest stays at rest, and an object in motion stays in motion with the same speed and the same direction, unless acted upon by an unbalanced force.
Unbalanced.
In simple words, it means that the objects continue to do what they're doing unless some external unbalanced force acts on them. We can also understand this using a simple diagram. If the forces are balanced, there can be 2 cases. An object may be at rest, or an object will be in motion at a non-zero constant velocity in a particular direction.
What?
These can be the only 2 cases when the forces are balanced. In the first case, the object will continue to remain at rest, and in the second, the object will continue to stay in motion at the same velocity and in the same direction.
So if balanced force is something staying still, it's going to keep on staying still. But if something's already moving and there's unbalanced forces, there's nothing to slow it down, so it's just going to keep on staying the same speed and velocity and the same direction. So when forces are balanced, it just means the object is staying the same, either staying at rest or staying at the same speed or acceleration. I mean, not velocity, not acceleration. It's just staying the same. That's all that means.
Don't forget, these 2 cases will remain true only if the forces are balanced. In the next video, we will look at a few applications of the first law of motion.
All right, quiz time. Was it possible for the runner to stop running in 1 second? Well, she said no, and that makes sense. Like if you've ever tried to slow down while you're running, it takes a little bit because your body wants to keep on moving. You need a big force to make it stop. We're gonna talk more about the size of the forces needed to make things stop the next video. So I would say no, you can't stop in 1 second when you're running. An object at rest will remain at rest. Is that true or false? Well, we know from just looking around our house that things are not moving, they're staying at rest. So we're going to say that's true. If something's at rest, it's going to stay at rest unless you add a force. So if you went and your brother's sitting on the couch not moving and you went and tackled him, he would not be resting, or he'd be accelerating towards maybe the floor, and then his fist might be accelerating towards your face. Don't try it. But if something's staying still, it's going to keep on staying still until something makes a change. What's the only way to make an object change its motion? By adding unbalanced forces. So you either got to push or pull it, or that's it. Add an unbalanced force to make it change its motion. Hit submit. Woo woo. 3 out of 3 because I'm the boss. 100%. Alright, so thinking back to the video of the car crash dummy, how did inertia play a role in that situation? Why did the dummy crash into the front of the car? So there's 2 parts to this question, so you need to answer both parts. How did inertia play a role in the situation with the car crash dummy? Second part, why did the crash dummy crash into the front of the car? So inertia played a role in this situation because the car stayed in motion until the wall added an unbalanced force, causing the car to change its motion. So that car was just going to keep on moving until something made it stop. That car had inertia. But the wall added an unbalanced force, causing the car's inertia to stop its motion, unbalanced force. The second part, the car crash dummy hit the front of the car because it was in motion and stayed in motion until the front of the car added an unbalanced force and made the dummy stop. So that crash dummy also had inertia. It was going to keep on moving until something made it stop. So even though the car stopped, there's still that space in between the dummy and the front of the car, and it kept on moving until it hit the front of the car. You might have felt this before, like if you were driving with a parent and they had to slam on their brakes really fast, and you kind of flew forward until your seatbelt caught you. That's because your body had inertia, so it was just going to keep on moving until something made it stop. So either the seatbelt made it stop, or the seat in front of you. That's why you need to wear seatbelts. I'm not joking. It's physics. You could get really hurt if the car stopped all of a sudden because you got so much inertia. Boom. You could go through the front of the car. It's really bad. Always wear your seatbelt. Say it after me. I will always wear my seatbelt. Okay, got that off my chest. When the car crashed into the wall, the crash dummy right here continued to move forward because it had that space, nothing stopping it, because it had inertia. It was resisting the stopping motion of the car. So this dummy did not want to stop. It kept moving until something made it stop, either the steering wheel or the airbag or the seatbelt. Wear your seatbelt. We're going to watch or go to this little website. I want you to read more about Newton's first law and watch the animations at the bottom and be ready to answer some questions in a quiz. Great, you can see me now. Alright, so the first law of motion, according to Newton's first law, an object at rest will remain at rest unless acted on by an unbalanced force. An object in motion continues in motion with the same speed in the same direction unless acted on by an unbalanced force. We call this the law of inertia. We know that. But what does it mean? This means that there is a natural tendency of an object to keep on doing what they're doing. All objects resist change in their states of motion. In the absence of an unbalanced force, an object in motion will maintain the state of motion. That's just a fancy way of saying all things are going to stay the same unless something makes them change. Objects keep on doing what they're doing. It's pretty simple. Looking at the skater. What is the motion in this picture? So what's the motion? What is the unbalanced force in this picture? What's causing a change in motion? And what happens to the skater in this picture? This law is the same reason why you should always wear your seatbelt. Watch. They're driving, unbalanced force, nothing, the inertia flies out of the car, probably got really hurt. Hopefully now you understand Newton's first law of motion. We aren't going to the second law until tomorrow or whenever you watch the next video. Alright, so we're going to minimize that. Here, I'm back. Some quiz. 6 questions. This is like your exit ticket. True or false? Newton's first law of motion states that objects at rest will stay at rest, and an object in motion will stay in motion unless acted on by an unbalanced force. Is that true or false? Rest is going to stay at rest. Moving is going to keep on moving unless an unbalanced force. I would say that's true. Another name for Newton's first law is the law of movement, the law of inertia, the law of motion, the law of rest. Well, I remember we just read about, it says another name for this is the law of inertia. I'm going to click B. Blank is the tendency of an object to resist change in motion. What's that vocabulary word? Gravity is the tendency of an object to resist change in motion? No, gravity just means pulling to the center of the earth. Acceleration is the tendency of an object to resist change in motion? No, that just means to speed up or slow down. Mass is the tendency of an object to resist change in motion? No, that's just the measure of how many particles is in something. Inertia is the tendency of an object to resist change. Remember we said inertia just means things want to stay the same. I'd say that's true. D is my best answer. On Earth, what force or forces might affect the motion of moving objects? Thinking back to that soccer ball picture. What forces might make moving objects change their motion? Friction, gravity, friction, and gravity. Well, I remember gravity is pulling the soccer ball down, and the particles in the ball were rubbing against the particles in the air, causing it to slow down. So I'm going to say both friction and gravity. Imagine being somewhere in the universe that has no gravity or friction. While you're there, you throw a football. The ball will what? So you're on a planet where there's no air and there's no gravity. So there's no friction, no gravity. What's going to happen to that ball when you throw it? It's going to move forward and then eventually stop and fall to the ground. It's not going to move at all. It's just going to go bloop. The ball will keep moving because there's no unbalanced forces acting on it, or none of the above. Well, I'm thinking inertia, an object's going to keep on doing what it's going to do. So once you give a force, that football is going to keep on moving until something makes it stop. Well, if there's no gravity to make it stop, and there's no friction to make it stop, there's nothing to make it stop, so it's going to keep on doing what it's doing, so it's going to keep on flying through the air. So that's what I would say. C, the ball will keep on moving because there's no unbalanced forces acting on it. Last question. When you visited the last website, there were two animations. What was the unbalanced force in the animation with the skateboard? So what caused the skateboard's motion to change? The skateboard, the rock in the road, or the skateboarder? So I saw the skateboard was going until it hit something that made it change its motion. It hit a rock. So I'd say the unbalanced force is the rock in the road. Let's see how I did. Woohoo, 100%, 6 out of 6. Thanks for watching. Hopefully you remember now that Newton's first law means things are going to stay the same unless an unbalanced force changes them. So if they're sitting still, they're going to keep on sitting still unless something makes it change. And if an object is already moving, it's going to keep on moving in the same speed and direction unless something makes it stop. We call that law, or that special vocabulary word, inertia. If you want to go over and watch any of the parts, you'll just hit the tap to restart. Always remember, you're welcome to call or text if you have any questions or need help logging on to Nearpod. Hope this was helpful. I'll talk to you guys later. Bye.